Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to look at solving a system of three equations in three unknowns algebraically. So when we have a system of three equations in three unknowns, the amount of work that we have to do is substantially more than when we have two equations, two unknowns. There are two ways that we can solve. In this video, I'm going to talk about the algebraic method, and in the next video, I'll talk about how you can use determinants. Again, the best way to explain this is to use an example, and hopefully I can fit it all on my board. When you're dealing with three unknowns, you do need three equations, just like we needed two equations when we were working with two unknowns. There's a lot going on because we have three equations and three unknowns, but when you're doing this algebraically, your goal is to eliminate one of the variables twice. Look at all of your coefficients to decide which variable is easiest to eliminate. So I look at my coefficients for A, I look at my coefficients for B, and I look at my coefficients for C. B has the lowest and easiest coefficients, so that's the variable I will eliminate. And what I mean by eliminating it twice is I work with two of the equations and do my addition, subtraction, or elimination method to eliminate B in this case. And then I pick a different two equations and I do the same process of addition, subtraction, or elimination, and I eliminate B again. So let me show you what I mean. I'm going to number my equations. This is equation 1, this is equation 2, and this is equation 3, so that you can see exactly which equations I'm using and what I'm doing to those equations in the process. So equation 1 is going to be a good one to use because my coefficient for B is 1. So if I take 1 and 2 and I multiply equation 1 by 2, I'll be able to add the equations and eliminate the B. So equation 1, I'm going to multiply by 2. So I'll get 8A plus 2B plus 6C equals 2. It's the same equation. When you multiply the equation by a number or divide by the same number, it's still the same equation. Equation 2, I don't have to do anything with it. Because these are opposite in sign, I can simply add the equations and I'll eliminate the B. So I will have 10A, that's gone, plus 12C equals 13. I'm going to number that equation 4 and I'm going to come back to it. So it's a new equation, but the nice thing about it, it only has two unknowns. I'm going to do this process again. And remember, I have to eliminate the same variable again, but I have to use a different set of equations. So I've used 1 and 2, so I either now have to use 2 and 3 or 1 and 3. Again, looking at what's easiest, I'm going to choose equations 1 and 3. And if I take equation 1 and multiply by 3, I will be able to eliminate the B term again. So I'm going to get 12A plus 3B plus 9C equals 3. Equation 3 I leave as is, 6A minus 3B minus 12C equals 4. Because these are opposite in sign, I can just add the two equations. So I will get 18A, I've eliminated my B term, minus 3C equals 7. So I have a new equation and I'm going to call it the equation, I'm going to number it 5. But what I have here is two equations in two unknowns. We already know how to solve that. So I'm going to do that using my elimination method again. So again, looking at my coefficients, 10 and 18 for A, 12 and negative 3 for C, it makes the most sense to eliminate C. I can leave equation 4 as is, 10a plus 12c equals 13. I can take equation 5 and I want to multiply it by 4. So I'll get 72a minus 12c is equal to 28. I'm going to add the equations because these are opposite in sign, and I'll end up with 82a equals 41. So a will equal 41 over 82, which is 1/2. I only have one of the 3 solutions, but what I do next will be easier than what I've done so far. So I have a equals 1/2. Let's find next. Let's go to either one of these equations and plug that value in so that I can find C. I'll just pick this equation 5. So equation 5, if I plug in 1/2 for A, I will get, when I move my terms around, I'll get 3c equals 2. So C will equal 2/3. I've got A equals 1/2, C equals 2/3. I just need to find B. Now that I have A and C, I can put those 2 values into any one of these 3 equations to find B. I'll pick the first equation. So 4 times 1/2 plus B plus C times 2/3 is equal to 1. 2 plus B plus 2 equals 1. So B plus 4 equals 1. So B is equal to -3. There's my solution. I want to do a check to make sure that it is correct. I know it's correct for equation 1, so I need to check my 3 values in this equation as well as this equation. So if I take equation 2 and put the values in, it works. And if I do the same thing in equation 3, it works for that equation. So I know that this solution works for all 3 equations. Let's take a look at another example. If you encounter a question where you don't have all 3 variables in all of your equations, use that to your advantage. It's actually going to make it easier for you. So I notice here that one of my equations just has y in terms of x. So what I would do is I would replace the y with 3x in these 2 equations, and then I end up with 2 equations in 2 unknowns. So I would take equation 1, and I'll have x plus, instead of a y, I'll put 3x minus 2z equals -4. So 4x minus 2z is equal to -4. I'll take equation 2, and I'll do the same thing. So I have 2x minus y, so minus 3x. I do the substitution, plus 4z is equal to 15. I simplify this. So now I just have 2 equations and 2 unknowns. So I don't have to go through the long process I did before. So you can do these kinds of shortcuts when you're missing some of the variables in some of the equations. It actually becomes easier for you. Now we have 2 equations, 2 unknowns. I'm going to eliminate the x by multiplying equation 2 by 4. So I'm going to keep equation 1. Equation 2 I'm going to multiply by 4. So I get negative 4x plus 16z is equal to 60. I'm going to add these two equations because they're opposite in sign. So I'll get 14z is equal to 56. So z will equal 4. Once I have that, I can put it in my equation 2. Negative x plus 4 times 4 is equal to 15. So negative x plus 16 equals 15. Move things around, get x isolated, x will equal 1. I can put that in. Y equals 3 times 1, so y is equal to 3. I'm going to do a quick check. So my solution is the set of values x equals 1, y equals 3, z equals 4. If I put those values into equation 1, it works. If I put those values into equation 2, it works. And I don't have to put it into equation 3 because I used that to find y. So I've done my check. I know that my answers are correct. I want to do one more example, and this one is similar to the last example. It has 3 equations, but in one of the equations there's only 2 unknowns. In this example, I already have one equation and just 2 unknowns. So that means I just need to use this equation and this equation to eliminate the same unknown as what is missing in this one. There's no s, so that means if I can eliminate s out of using these 2 equations, then I'm going to end up with a second equation with these same 2 unknowns. Let's number these, and I'll show you what I'm talking about. I want to eliminate the s, but I only have to do it once. So I take equation 1 and equation 3. Because s has the same coefficient opposite in sign, I don't have to do any manipulation. So equation 1 and equation 3. Because those are opposite signs, I'll add the equations. So I'll get 3r plus t equals 0. It is an equation in the same 2 unknowns as this equation. So I don't have to eliminate s again. I just use these 2 equations, 2 and 4, and I'm going to choose to eliminate the t so that I don't have to do any manipulation on my equations. So I'm going to take equation 4, I'm going to subtract equation 2. So 3r minus r is 2r. T minus t is gone. 0 minus 2 is negative 2. So r is equal to negative 1. Once I have r equal to negative 1, I can put it into equation 2 or 4. I'll pick equation 2 and solve for t. Add a 1 to both sides. So t is equal to 3. Once I have r and s, I can go to either equation 1 or 3. I'll go to equation 1 and plug in r. Sorry, I might have said s before. I plug in r and t and I find s. So I have negative 4 plus s equals negative 3. I add a 4 to both sides. Again, I'm going to do a check. It does, so it's correct. I know that these equations are difficult to solve because they take a lot of space, they take a lot of time, and they take a lot of manipulation. But they do get easier with practice, and you may not really like the algebraic method, and you may prefer determinants. And I'm going to cover determinants in the next video. So try some algebraically and see how you make out. Rewatch these examples if you need to, and then when you're ready, take a look at the next video. Till then, take care.